stuff that we really need to cover. So we'll do our best to get through it. Today's nice and short, and I very well might be able to get your work done in class. So average rate of change, this is where we want to start. We're going to talk about two things today, average rate of change, and then where functions are increasing and decreasing. And this is just a nice little intro for something that you will someday see in calculus, especially some of the notation. We call average rate of change is basically the slope. Hey there. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So what that means is if I'm given coordinates x1 and y1, and then other coordinates x2, y2, I can use the slope formula and find the average rate of change between those 2 points on the given function. Now, there's another way to write this. We're not going to use this necessarily, but if you were to see it, this is what you do. Instead of y values, I just talk about the function values. Instead of x1 and x2, I just use a and b. So your coordinates for this would be, if you have coordinate a for x, you would have f of a for your y coordinate. And if you had coordinate b, you would have f of b for your y coordinate. Does that make sense that those are the same? Okay, here's the last way that you'll see it expressed. It looks like a triangle. The triangle is the capital letter for delta in Greek, and it means in mathematics, it means change. The change in y, or the subtraction of the y values, the difference of the y values, divided by the change in x. Change in y over change in x. So, just last hour was wondering, the little letter for delta in Greek is that. So, capital, lowercase, in case you were wondering. Now you know. And knowing's half the battle. All right. So, let's do some average rate of change right here. Did anybody catch that G.I. Joe reference? No? Did anybody watch the new movie G.I. Joe? You did? So G.I. Joe was so huge when I was growing up. And that was always one of the phrases they used in the G.I. Joe songs. Knowing is half the battle. G.I. Joe, the real American hero. So if that's a function, if the blue, and you don't have to draw this perfectly, I wasn't able to put it on your paper, I apologize for that. But if that's f of x, okay, and you want to find the average rate of change, all that means is I'm going to look at the difference in the y values divided by the difference in the x values. And right here on this function, I have a height of 4 right here. It looks like it drops all the way down to 0. So my change in y is -4. For my x, I go over 5 and then 6 more. So I went over a total of 11. So -4 elevenths. You go down to the spot of -5, but it has a height of 4, so you drop 4. So, graphically speaking, that's all we're doing. So let's do it algebraically. Just for an example, we could have chose any points and find the average value, average rate change. Yep. Oh, yep. Average rate of change on a given function is an infinite number of answers. So here's what we're going to do. We're going to determine the average rate of change of the function between the given values of x. So if we specify that our values are between -2 and +4, we're going to find the average rate of change. Well, all I do is I just find the two coordinates. So I have x is -2 and I have x is 4. What am I missing? Need the y values. How do you find the y values? I got x. Plug them in. Yeah, f of x is 4x minus 3. Plug them in. 4 times -2 is -8. Minus 3 is -11. 4 times 4 is 16. Minus 3 is 13. We've got them. Now that we have the points, we're going to find the average rate of change. 13 minus -11 over 4 minus -2. What's 13 minus -11? 24 divided by 6 is 4. It's all right. You can multiply. Should always feel comfortable to make an incorrect answer in a class. It's a sign of a healthy classroom environment. Or if you're getting bullied by people behind you, that we could bring that up. Yeah. Also a sign of a healthy classroom. There we go. All right. Any question? I got the average rate of change. Are you surprised that this function has an average rate of change of 4? No, it's a line with a slope of. Yeah, we knew it was going to be that from the beginning. Let's try something that we don't know from the beginning. Okay, if we got -2 and +1, what is the y value for an x value of -2? -10? 3 times -2 is -6, minus 4 is -10. Then plug in 1 and we get dose. Use our rate of change formula, otherwise known as slope. 2 minus -10 divided by 1 minus -2. What's 2 minus -10? 1 minus -3 or -2? 3. No, the answer is not always 4. Just wouldn't that be a great lesson? What do we do today, Mr. Gens? Just always write 4 for the answer. Be pretty boring. All right, answer is not always 4. Just happen to be in that situation. All right, so we leave that behind. Average rate of change. You okay? Awesome. This is even easier than average rate of change. Identify the intervals on which the functions are increasing and decreasing. Increasing means the slope is positive. Decreasing means the slope is negative. So let's look at this graph right here. Moving left to right. Am I going up or going down? Up. The slope is positive. So therefore, I am increasing. And I'm increasing from -5 all the way to -2. You can see those spots. What happens after that? I decrease from -2 to 2. What happens after that? Stays the same. Slope of, yeah, so I guess maybe you could write 0. I have a slope of 0 from 2 to 4. What happens after that? Increase from 4 to 5. And when we express intervals of increasing and decreasing, we always use parentheses. We don't use brackets. We don't say you're increasing or decreasing at a corner or an endpoint. It's unclear really what happens at those spots. It's more of an analytical topic. We're not going to get into that right now. Okay, the next one, well, that one's got an arrow on the end. So if I start, say, right here, is my function going up or is it going down? If I move from right to left, it's going down. But if I move from left to right, I'm going up. So I am increasing from negative infinity to, what's that top spot? Yep, negative 3. What happens after that? Right, because if you think of it like this, if I throw an object up, its height is increasing, and on the way down, its height is decreasing. But what happens right at the top? It stops. It's motionless for a billionth of a second, right? There's just that small point in time where it's not doing anything. So we can't call it increasing or decreasing right at that spot. Okay, so then it decreases after that from negative 3 to what? To 1. What happens after that? From it's like from 1 to 4. And then it has a slope of 0 after that, doesn't it? From like 4 to infinity. How's that? Easy peasy? You're like, wow, this is not too bad. No. It's a nice little lesson. Question? So from negative 3 to positive 1, it's going down. Right in this interval right here. And it's going up between 1 and 4. We just got to do these two bottom ones on our calculator. All right, take out your calculator. Let's have some fun. Juniors, yesterday we talked with the seniors about what their plans were for college. We had a special day. We bonded. Yeah. Oh, for the TI-84? I don't know how to do that. Anybody know for your TI-84, like you can have like, it's like the equation entering help thing. It creates a big box. Anybody know how to get rid of that? We'll try to take it off later. I'll see if I can take it off. It would bug me too. I can't stand it. All right, let's enter the equation. X to the third minus 9x. And what we want to do is it says look at the graph and identify the intervals of increasing and decreasing. So we're going to do that. And so we all see the same window. I'm going to press zoom. What? 6 for standard. Now, I would like to see the graph in a little bit different window. I want to see higher up and lower. I also want I want to cut off some of the right and the left. Now, after our calculator exploration, I'm trusting that you guys, with your knowledge, especially last year, that you could adjust your window. So you can do it however you want. This is just what I'm going to do right now. I'm going to cut off some of my x values so I don't see all that wasted space. So I'll go from -6 to 6, and then I want to see more of the top and bottom portion. So I'm going to go from -20 to +20. And then one thing you'll get to know about me is I can't stand all the tick marks. I can't stand it. Right now I would get 40 tick marks because I have a tick mark every one spot, and I'm from -20 to +20. So I change that to 10. That way I'm going to have very few tick marks. That's just, everybody's got their preferences, and that's just mine. Isn't that a beautiful graph? So you tell me, am I increasing or decreasing right here? Increasing. So we have an interval of increasing from -infinity to some other number. You guys tell me when I stop increasing. Yeah. What do we call that spot on the graph? Maximum. It's a maximum in this general area. We all know the graph goes higher over here. However, right at this spot, you do have a maximum. So we go second calculate, and what do we grab? Number 4, maximum. We go over to the spot. When we get to the spot, it says, what is the left bound? So I'm going to move to the left of that maximum. Now I'm going to move to the right of the maximum. And if you want to press guess, just, you can move to the spot, press guess. It really doesn't matter in this situation. And what's the result? negative 1.73, and that actually happens to be negative roots of 3. You don't have to write negative roots of 3, but that's the exact answer. You learn how to find the exact answer in calculus. You can do it algebraically. You don't have to use your calculator. It's pretty cool. And what happens to the graph after that spot? I decrease. And I'm going to go from negative 1.73 to, what do we call that spot down there? A minimum. So I'm going to go second calculate. I'm going to do 3 for minimum. Go down to my spot. It says left bound, so I move to the left. Then I move to the right. Just enter on guess, and what do you notice I get? Yeah, or the square root of 3, we're going to get basically the same result. Just positive. What happens after that? Increases from 1.73 to infinity. Any questions? How I did that? Yes. I don't care. I'm not going to get that picky. I'll never forget, though, on my calculus test, my Honors Calc 1 test from my freshman year of college, I had the whole answer right. But in my work, I forgot to write down dx somewhere, which is just notation. It took 2 points off, so I got 98 out of 100. And he said, I know, Kevin, it doesn't matter, you're going to get an A in the class. I said, I just wanted you to know that even the small little things in mathematics do make a difference later on. And so I understood what he meant, but I sure would have liked those 2 points back. I'm not out to ding you for points, okay? I'm not out to try to do that. Negative 2. And then cubed root. So if you want to enter cubed root, you can go to math, and you can choose like number 4. Or you can put a 3 down and choose number 5. That will tell you it's the cubed root. Or you can do what I do. I don't do either of those. I do negative 2, and I do x minus 3 to the parentheses 1/3 power. That's what I do. I take it to the 1/3, because that's what it means to take a cubed root. Plus 1. So again, you can go in math and grab something else, or you can just do this. Any questions? Ready to graph? Is that a yes or a no? Got it? All right. Zoom 6. Is the graph going up or down? Down, 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 down. And it's still going down, isn't it? In fact, is this graph ever going up? No, this graph is always decreasing except for one spot. What is the only time you can't find slope? A vertical line, straight up and down, right? For exactly one time in this graph's life, it does go exactly straight up and down. Right here. See, your calculator even has a hard time drawing it. It's got like 3 or 4 pixels stacked on top of each other. Technically, that's a spot where the graph is going straight up and down. And so we have to exclude that. It's not increasing, it's not decreasing. It's just it's undefined. So what we do is, how do you find that spot? There's no special calculating button to find that spot. If you look at the tick marks, what does it look like it's at approximately? 3. And if you notice, this graph is shifted over 3 units, so it is 3. So we would say decreasing from negative infinity to 3, and then from 3 to infinity. So we just excluded that one value. Question? One more time. If I press trace, the point on the line exists. The slope doesn't exist. So, like, for example, in calculus, we learned to write a new equation for slope. And when we come up with that slope equation, you would have something like this in the denominator. And you would see that, oh, x can't be 3 for the slope equation. So that's what we would eventually find, okay? But for the actual function, it does have values there. There's not an open spot. There does exist a value, but the slope does not exist at that spot. It's the x minus 3 that shifts it over 3 units, so that's one way we can figure it out. I won't give you anything difficult like that. I just want you guys to see an example. So, okay, here's what you got: 2.4. Some of these are pretty straightforward, easy problems where you're just simply doing y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You have this right here. And then juniors, after you write it down, I could show you what we did yesterday. That takes about 15 minutes. So now I can stop recording.